All right. Here's one. Here's a question that came in from 6.5, and I believe that's the section on related rates problems, and that's where you'd actually need to be able to do a computation like this to do a related rate problem. So think of it this way: for this problem, it says assume x and y are functions of t and evaluate dy dt for blah with these conditions. Now, the way you should think of it is x and y are quantities maybe that vary with respect to time, time being t, okay? And the quantities x and y are related together by an equation like this. Okay, so what I can think of is the left-hand side is a function of t, a function of time. The right-hand side is a function of time. It's a simple one, actually. It's a constant function of time. And equal functions have equal derivatives. So we can find a time derivative, rate of change of y with respect to t, by using this equation that relates the variables possibly, but also using one that equates their derivatives. And so what you do is you take the derivatives of both sides, equal functions of t have equal derivatives, and you use that to isolate the dy dt that you want. So here's what I was looking at here. I started off with the equation that was given. It's an equation between x's and y's and equals minus 205. And what I want to do is take time derivatives of both sides. So I did ddt of the left equals ddt of the right. And I just went through and computed. Okay. So on the right hand side, the derivative is just 0 since it was a constant. On the left hand side, there's some product rule. There's a product rule in the first term, and there's chain rules in basically every term. So first things first. When I do ddt of this first term, it's 4 times the x derivative with respect to t plus times y plus 4 times x times the y derivative with respect to t. Okay? And so if you look at it, that's exactly what I've got. It's the product rule. One was dx dt, the other one was dy dt. Minus 2 dx dt from the second term. And then in the third term, I've got 5y squared, 5 times 3y squared dy dt. So 15y squared dy dt. Now the idea, the goal of the problem is find dy dt, so isolate that. So basically what you do is you take the dy dt terms and you leave them on one side and put the non-dy dt terms on the other side. So that's exactly what I did. The second term here and the fourth term here I left on the left. The other two I pushed over to the right-hand side by adding this one on, subtracting this one off. Then I factored out the dy dt. Okay. Now if you wanted to truly isolate dy dt, you could divide by this side, but I chose not to write down a big fraction. I just left it as this multiplication. And now the goal was, okay, so I found what dy dt looks like in general. This is like an equation that relates the rates and the variables. But I want to find it at a specific instant, which is the time, whatever time it actually is, where dx dt is negative 15, x is 5, and y is negative 3. So if I plug those values in to this equation that I just found in general, I can isolate dy dt, and that's exactly what I did. I just plugged all those variables in, simplified, divided by whatever that is, 155, and simplified the fraction.